Hi there, let's take a look at section 5.3, which is about graphing radical functions. What's a radical function? There is a square root or a root radical something or another in the equation or function in that matter. We have two different functions that we'll look at more specifically today, the parent functions for a square root and a cube root. Now, when it comes to a square root function right here, it pretty much looks something like this. There is a starting point for the parent function. It's at the origin, and it's going to go up and to the right. You're saying, well, why doesn't it not go down? Why doesn't it go the other way or opposite direction or all this and that and the other? Remember, inside of the radical, which we call, once again, the radicand, it can't be negative. Right? If I plug in a -4 into here, do I get a legitimate answer? No. You get an imaginary number. So therefore, at 0, it's okay, right? If I plug in 0 in for x, where does 0, 0? That's where we got 0, 0 for. I plug in 1 for x, the square root of 1, I get 1. There's our point, 1, 1. But once I start plugging in negative numbers, that is no good. So all radicals will look something like this, whether it's to the square root, fourth root, sixth root, even functions, all right, even indexes. Sometimes it could go down like over here and up. It could go starting point and go to the left because of reflections and all that stuff, which we'll talk about more so. As far as the domain and range, you could see that the domain, once again, your values of x, it's going to be everything that is greater than or equal to 0. Starting right here, and everything greater or to the right is your domain. Your range will remain the same. It's going to be y, values of y greater than or equal to 0. But it'll all be based on where that starting point happens to be. Now, for the next one right here, we have the parent function for a cube root. A cube root happens to have this S-shape looking function or graph. There's three main points that you're always going to be looking for. One is where's the middle, okay? What do you mean by the middle? This one happens to be in the origin. Point 1, point 2, point number 3 right there. Now, remember with cube root, it works out nicely that you can have negative numbers, right? So let's say right here, I want to figure out what my points are. I'm going to just go ahead and use -1, 0, 1. If I plug -1 into here, I can get an answer because -1 times -1 is +1. Multiply that again by -1, you'll end up with -1 for y. And that's how we get this point down right here, -1, 1. You plug in 0, you're going to get 0. You plug in 1, the cube root of 1 ends up being +1. And so we have ourselves this S-shaped function. You do not draw a straight line that goes through those 3 points. Not in cube roots or when the index happens to be odd. Domain, remember, it keeps going left and right. So all real numbers for your domain. It actually keeps creeping up to the right and down to the left. So that means that your range will keep going and be all real numbers as well. Let's go ahead and move on along, and we have all of our translations. Very similar to everything that we've looked at in chapters 1, 2, and 3 with, when it came to parabolas and absolute value. What I care about is what's inside of the radical. Okay, if it's inside the radical, then right here, you can see that it shifts it left and right. -2 plus 3, if you go -2, it shifts it to the right. It's going to be the opposite, right? Because if you take x minus 2 and you set that equal to 0, you'll get a +2, which is to the right of the number line. So remember, and this affects right here, if you think about it, what is it impacting? Input, output. We keep talking about that. This happens to be your input. Is directly affecting the x. For vertical translation, the numbers that affect moving it up and down will be on the outside of the radical. So you can see right here, plus 7. We just add 7 to the outer and minus 1 to the outside. Vertical translation, output. Output affects the whole entire function. That's why they put f of x plus x to, because you're going to add to the whole entire function itself. We've got our reflection right here. Y-axis reflection, input, x-axis reflection, output. Right, so y-axis reflection, it will be on the inside, affecting directly the input. The x-axis reflection right here will multiply the whole entire function itself, its output. Horizontal stretch, shrink. Remember, this one's very tricky because it's almost counterintuitive, but when it's horizontal stretch, you're actually going to take the function, if they say stretch of 2, you're going to take the reciprocal of that, which is 1/2. And this right here is, sorry, because horizontal stretch or shrink, you'll take 1/2 for stretch. And if it's shrink, you're going to take a factor of 1/3. You're actually going to take the function, or x, and multiply it by 3. Vertical stretch and shrink. So remember, both of these happen to be input. But for vertical stretch and shrink, it's output. And do you need to worry about the reciprocal? No, not for vertical stretch and shrink. Okay, so don't forget, horizontal stretch, shrink, input, and then also reciprocal for your numbers. Okay, and there you have all your rules kind of explained in a nutshell once again. So let's do some graphing here. Let's take a look at number 1. I look at this function and I see a, excuse me, I look at the function right there and I know that this should be an S-shaped function. Now there's other things that I should be taking a look at. Right here, this negative, it's on the inside of the radical. It's directly with the input. So that right there should tell me we have a y-axis reflection. Out here with the +1, it's on the outside, so it's affecting the output. That's going to be vertical translation. Okay, so vertical shift, up 1 unit. So how do I figure out the rest? Well, we always want, it's like when we did parabolas or quadratic functions, we want to find the vertex first. So let's figure out, well, where is this middle point? Okay, the middle point right here, remember, this will tell us whether it's shifting left or right. Horizontal transformation or translation, but there is no horizontal, but it's moving up 1. So that tells me that the middle, remember, there's 3 points whenever we're dealing with this S-shaped function. The middle will be right here at 0, 1. How do you know that? Because I could read this and extract the information out of this function right here. So there is the first point, 0, 1. Let's figure out some other points. Well, what I want to try to do is figure out, well, what are numbers that I could take the cube root of? That's going to make things a lot better. What numbers can I take the cube root of? So think the first one would be 1, but that I can't get 1 from -3. So how about we'll try 8, right? There's a cube root of 8, but can I somehow get this number to turn into 8. 3 times what will get me 8? Not a whole number, right? So that doesn't work. So let's go to the next number, 27. I can somehow get 27 here, can't I? And the cube root of 27 is 3. How do I do that? How about I plug in 9 right there? So we could do two things. We can plug in a negative 9. I could also plug in a positive 9. I could do both because that will both get me 27. The square root, or so if I plug in negative 9 right here, then I end up with 27. The cube root of 27 is 3. 3 plus 1 will be 4. So one of our points is at 9, 4, or negative 9, 4. Let's plug in positive 9 next. And so you'll have the cube root of negative 27, which will be negative 3. And then negative 3 plus 1, negative 2. So let's go ahead right here. To make this work, I'm going to have to say intervals of 2. Right, so we got negative 9, 4. Let's go ahead and do intervals of 2. This is negative 9, up 1, 2, 3, 4. We'll keep the values of y intervals of 1, but the values of x intervals of 2. So there's our 1 point right there. And then at 9, negative 2, we'll have it right here. And so, as we put things all together, it should look something like this. It's like this S shape, but it's going the opposite direction. It should, right? Because look, we said in the beginning, hey, look, negative 3x in the radical, or in a radicand, that's y-axis reflection. So it got flipped around. Instead of being a normal S, it's a backwards S. It's all there. Okay, let's take a look next up at number 2. You try to make things a little more fancy and tricky, but it really isn't, because you know what the exponential, how you could take an exponential exponent and rewrite it into a radical. This right here ends up being the same thing as g of x is equal to 2 times the square root of x minus 5 minus 4. So, knowing that these are both the same, you take your pick. If you could work with this, the original equation, then work with it. But if you could rewrite it, then do so, because now it makes a little more sense to me. This 2 right there, that should tell you you've got yourself a vertical stretch. X minus 5, we take the opposite, so we got ourselves a horizontal translation. And then this minus 4, we got a vertical translation. This is going down 4 units. This right here tells me it's going to go to the right 5 units. You take that x minus 5, set it equal to 0. All right? So remember, the first thing we want to do is figure out, well, where exactly is the middle? Okay? So remember, this right here, if I take the x minus 5, you set it equal to 0, x is equal to 5. And then we have negative 4. So the starting point, okay, the starting point right here is 5, negative 4. I got that just from the equation, just looking at it, being able to extract the information and all that we've done throughout the school year. So let's go ahead. We got 1, 2, 3, 4, 5. 1, 2, 3, 4. 5, negative 4. That's our starting point. Now, remember, this from here, it cannot go to the left. It cannot go down. It can't go past that to the left. Okay? Now, the only way it could is that if there was a y-axis reflection, but there's none of that here. So what I'm going to do is let's go ahead and we'll plot some points, and I'll start off with 5, negative 4. Okay, You don't want negative 1, 0, 1, and 2 because remember, if I were to plug in, let's say 0 into this function, what ends up happening? 0 minus 5 is negative 5. You cannot take the square root of negative 5. So you must, that's why we can't use that number, and I have to start with positive 5 right here. So if I plug in 5, you end up with 0, right? Square root of 0 is 0. 2 times 0 is still 0. 0 minus 4 gets us negative 4. Well, what's the next number that I could take the square root of? 1. Well, how can I make the radicand equal 1? What if I use the number 6 right here for x? 6 minus 5 is 1. I can take the square root of 1 as 1. 1 times 2 is 2. 2 minus 4, negative 2. So there's our second point. Let's come up with the third point. Okay, at least 3 points. And so we have to think, well, what's the next number I could take the square root of? I could take the square root of 4. How can I get 4 right here for my radicand? How about the next number we use is going to be, hopefully you said it, and you're thinking in your head, 9, right? So we plug in 9 next because 9 minus 5 gets me 4. The square root of 4 is 2. 2 times the 2 on the outside is 4. 4 minus 4 is 0. So the next point is at 9, 0. And so now we've got 3 points. We can make this look pretty legit now. We got 6, negative 2. I'll plot a point there. 9 and 0. It's over here. And remember, it's going to have our starting point, and it is going to go up, and it's going to be curving just like that. And remember, it's stretching out. So you can see compared to the parent function, the gap in spacing that you start seeing is a lot wider. All right, moving along. Describe the transformation. Okay, it's a even index, so it's going to be right here, something that looks very similar to a square root, but that's not a really description. What ends up happening is usually it tends to stretch out more, but there's other things right here. We have this, so if we take a look at the differences, one of the things that stand out is we've got this negative on the outside, output. So 1, x-axis reflection. Okay, what else do we have? Look right here. Look at the difference from 5 to negative 5. That's quite a difference. That's quite a gap. How much did it actually change? It actually went down 10 units. Okay, don't think it's just 5. Okay, so it went from 5 to negative 5. So we can go ahead and say it went horizontal, or sorry, not horizontal, vertical, shift of 5 units, just like that. All right, let's see. Let's go ahead and take a look at, what can we look at right here? And it looks like we could do number 4, or we don't have to. So we're all done right here with 5.3, graphing radical functions. Remember, you got to at least have 3 points when you're doing these functions, when you're graphing them. Always try to start with the starting point. Remember, it's for even function or even index, it's always going to be, you can figure out where the middle is, or the starting point. But if it's an odd index, then you're going to find that middle number by looking at and reading the function itself and figuring out, is it shifting vertically or horizontally, and then you can find where the middle is. All right, so go ahead and get yourself graphing. please use graph paper here.